Okay, enough of that. Let me tell you a little bit about Stefano Diandra. He's an industrial graphic expert. Since 1989, he has dedicated his entire professional career to flexography, from design and pre-press to plate making and printing. During his career in the flexographic industry, he has covered several roles, including technical support to sales, product management, business development, education, and technical training. Since 2017, he has been dedicated exclusively to technical education in the flexographic process and consultancy as an independent professional. Stefano manages the Flexo.expert and Flexo.training websites and carries out teaching activities both independently and in collaboration with Italian and foreign technical institutions. He actively contributes to the activity of ATIF, the Italian Flexographic Technical Association, and FTA Europe. He is a member of TAGA Italy, registered expert to the ISO TC 130 working group through ATIF, and is also a member of the FTA US, where he has achieved his first implementation specialist certification. So with that, Stefano, I'm going to go ahead and turn it over to you, and you can take it away.
Thank you very much. Thank you very much, Joe. Good morning, good evening, good afternoon to everybody. Let me share my screen from here and start from here. Should be visible. Okay. So again, hello and welcome to this FTA Membernar. I'm really so proud and honored to be here and share with you the results of my work, and I hope it could be useful for you all. Today's session is a sort of continuation of what we have discussed during the FQC First Tech Focus meeting of last April 16. That was about SCTV or CTV dot area measurement. In case you missed the Tech Focus, just go to your FTA Member Connect area, go to Webinars, scroll down and click on Watch Tech Focus Webinars, and you can see why it's time to change the way you measure dot percentage. I won't steal your time today, but in case you haven't watched that presentation, there are a few things that we have to remind and go through. So during the phases of flexographic process calibration, in particular during optimization and fingerprint, we need to match a desired condition. And we do this by adjusting the tone values on plate, right? This condition is either represented by the characteristics of individual colors, like when we match ISO reference or CRPC curves, or the result of combined colors aiming to neutral grays. In case of individual color adjustments, we normally target to a reference curve like this one. So typically we print a linear plate to check the reproduction of tone values, and it may happen that the actual print condition shows a dot gain that is higher than what we expected. Therefore, we calculate and apply a compensation curve that will change the tone values on the plate during rasterization. So how do we do that? We have a reference target that says, for example, 50% is expected to print somewhere around 70, but it prints 80. Now, actually, we don't really calculate a compensation with a formula based on these three figures. So there is no algorithm or direct calculation between 50, 70, and 80. We actually search for what value, what plate value produce the value in expected at 50. That is 70, right? And we use that value as a compensation. So what value printed 70? Okay, it was something like 36. Let's pull down 50 to 36. And what about 30? It was supposed to print 45, but it printed 62. What was printing 45? 17. Okay, our 30% will be compensated down to 17. Okay? We do this for all the tone values that are needed to describe our compensation curve. And this will allow us to match the target reference curve. So let's see what happens during the phases of optimization, of calibration of our printing system with some real examples and numbers. So let's start with optimization. Okay, we design an artwork, our optimization test form that includes step wedges, that will contain certain tone values, and we produce a negative image. The negative can be either onto a separate film or directly onto a black ablative layer on the surface of the plate. And if we use a plate system that has no differences between the negative and the final plate, so a flat top with one-to-one reproduction capabilities, we can produce what we call a linear plate without any tone value adjustments, where 10 is 10, 50 is 50. So a 50% area on a linear plate will have half printable surface with dots that can receive and transfer ink and half non-printable voids. If we use a different plate system that requires other adjustments like a bump, we can see that later. We print our linear plate, we measure and we evaluate our results. This is what we call actual print or uncompensated print from a linear plate. And sometimes the printed tone values could be a bit too high compared to the expected or desired result. And what do we normally expect or aim to? Our expectation is represented by a target reference curve that describes the print.gain condition to match. The values of this curve are reported in different editions of the ISO 12647-6 and implemented in several workflows to standardize the reproduction of tone values before the application of other calibration techniques such as gray balance or repurposing with device link profiles. This curve could also be any of the target curves from the 7 CRPCs. Remember, here we are at the stage of optimization, so we are getting closer to a condition that will be better refined during fingerprint. From the current print and the target TVI, we calculate our dot gain compensation curve, or better, we search for our compensation values as we have seen before. And we produce a compensated plate that hopefully will match in printing what we expected. But sometimes the life is a little bit more complicated, because maybe the plate system that we use might not be able to hold the highlights that were imaged on the negative media. We have a shrinkage or even loss of tone values, as it happens with digital ablative plate systems. And normally, when using lamps plates that are sensitive to oxygen inhibition during plate making, we know that we need to add an extra compensation for this. We add a little bump in highlights to correct the plate reproduction, so that the final plate will have all the dots in all patches, including highlights. And we print, we measure, and again, here we might have a printed result that shows a dot gain that is rather, let's say, higher than expected. So we will apply a compensation on top of the bump. This could either be one curve, one single curve combining the values of the two curves, or two separate curves, one for bump and one for compensation. That's depending on the available workflow capabilities and the imaging RIP. Okay, so we have our bumped and compensated plate, and we can print, and hopefully the results are good and we are matching our target, with our 50% printing approximately 70 and matching the target curve. Okay, but where is this target curve coming from? That curve was actually derived from the curve C of FOGRA 27 characterization. Yes, we are talking of legacy characteristics related to offset printing onto paper substrate with offset plates, offset inks. This curve was adapted to flexography by adding a little bump in the highlights to accommodate for flexotypical behavior in those areas. Yeah, okay, but why should we match offset TVI in Flexo? Now, Joe, can you please launch the first poll? So I would like to ask a question to the audience. So how about you? What target curve do you use in Flexo? Do you match to ISO 12647-6 or any curve from CRPCs or other standards like FOGRA? Do you already use SCTV and target to linear? Or do you have any other custom reference for your, or maybe you don't know?
We'll give that just a minute here. We get
Sure.
votes coming in, Stefano. Okay, I'll launch those results for you.
Uh-huh. Okay, interesting, interesting. So the ISO curve is quite popular, and I I should have also asked if do you know if that the ISO curve comes from offset, but we would ask the next time. So regardless from that question, there is another question that is about the actual concept of dot area. You know that we call them both dot percentage on plate or on print. We use the same name, but they actually refer to two different aspects. A plate dot area is a mechanical value. We measure the area coverage of what could receive ink from the Anilox roller and transfer it onto the substrate. A printed dot area is an optical value. We measure the absorption of light created by the ink that acts as a filter on the substrate. And we know that coverage is influenced by voids, donuts, pinholes, slurring, everything that affects the ink laydown. The recently published ISO 20654 defines a new metric for the calculation of tone value, and its implementation is showing to be very helpful. This new formula is commonly known as SCTV, spot color tone value, because it was originally developed to measure spot colors only. And it produces approximately uniform visual spacing of the tones between the unprinted and substrate and the 100% coverage. I'm reading from the, from the text of the ISO norm. But the greatest advantage of this formula is that now, finally, plate mechanical area coverage and printed optical tone value are measured with two methods that are equivalent and that maintain proportional and visual spacing of the tones. With this measurement, optical and mechanical values are aligned. Finally, 50% on plate and 50% on printed substrate have the same meaning. They both express a tone value that is in the middle, okay, at the half, 50%, the half of the full solid and the not printing or printed elements, which is very good. Although this formula was created to measure dot percentage on spot colors only, the latest ISO norm 12646 related to flexography that was published last year in 2020 allows the usage of the SCTV formula to define the tone curves for both CMYK and spot colors. And this is really great, but this presentation is not about promoting SCTV. We have already done this and covered this topic, and you can find the video recording in your Member Connect area, right? Now, I want to show you how to use SCTV to simplify the creation of dot gain compensation curves in Flexo. So let's see how it works. Calculating the compensation curves from SCTV works exactly in the same way like with standard input values from Murray-Davis. It is just easier because the reference target is linear. So we calculate a compensation to change plate values in order to match a linear target. And we know how it works, right? So 50% was supposed to print 50, but in this case it printed 68, okay? What value printed 50? Something like 33? Okay, great. Let's compensate 50 down to 33. And then we can do the same for other tone values like 25, 75, and we can build our complete compensation curve with all the values that we need. Well, in fact, we cannot calculate a compensation with just a print value of 50, okay? We need more values to describe the curve. When we define a compensation just with a value of 50, we are not actually calculating it. We are actually selecting among existing curves that were previously calculated with a complete set range of values, okay? What happens when we compare compensations from Murray-Davis and SCTV? Well, when we measure in Murray-Davis, we target to a reference curve that was derived from Murray-Davis measurement, and we calculate compensation values. With SCTV, of course, we get different measurements for the same patches, but our target is now linear. And when we calculate our compensation, the difference might not be that much, okay? Don't expect them to be exactly identical, because they won't be identical, but they really won't be too much different. Remember, compensation curves are mechanical values on plate that are derived from optical measurements on print. Of course, if we have hysteric print curves, just like it happens with Murray-Davis, the compensation will try to run after such a wavy aspect, resulting in uneven distribution of the tone values in the compensation, with humps and hysterias that require smoothing. Okay, and when thinking about smoothing, we should observe that nature always has a regular and natural behavior. So if we started from a linear plate condition in a single color, for what reason should we insert hysteric curves to compensate for a possibly momentary behavior of our printing system? So that's a very good reason why compensation curves should always be naturally smooth. Okay, and how can we evaluate the regular smoothness of a curve? First of all, let's take a look at the print curve. When we evaluate printing curves, we normally look at the printing characteristic curve, a graph like this. This is the graph you see here on the screen with X and Y values. But this graph sometimes doesn't tell us at a glance what's really going on in printing. If we plot the same numbers with a TVI curve that considers the difference between the actual printed values and their expected values, we can appreciate more aspects and details in the print production. A TVI curve is expected to be somewhat like a regular hump, like a mountain, very smooth and regular, but here I see a sort of flattening in the midtones, right? And this is a typical behavior of a too soft cushion tape used for plate mounting. And this effect is definitely much more visible with a TVI graph rather than a normal characteristic curve. With TVI, I can change the scale of the y-axis, of the vertical axis, to amplify the difference and better evaluate my curve. So TVI plot allows a much better understanding of what's going on press. So from now on, I will only use TVI curves to illustrate this work. So if we plot a TVI curve from SCTV print values, we obtain a graph like this. And this is real data from Flexo print. Our target reference, our aim for SCTV tone values would be a flat curve. So 50% should be 50, okay? Thus 0% TVI, okay? So it's a line. Our target is the flat green line. We now calculate the dot gain compensation for that print curve and the target curve. And the compensation will look like the gray curve at the bottom, okay? From different TVI curves measured in CTV, we can calculate as many different compensation curves. Maybe because we have different Analox volumes, we have different substrate absorption, different screen count, and different print curves and different compensations, right? And here there is something very interesting. When we look at the shape of these compensation curves, there is something really noticeable. They all share a rather similar aspect in common. They are all quite symmetrical, you see? Actually, the shape is not just symmetric, the shape is actually an arc of circumference. Don't be misled by the scale of the vertical axis. It is really an arc of circumference here. Actually, I like to consider those shapes like arcs of circumference because I remember there was a guy at school some weeks ago that was discussing about circles. No? Euclid described the construction of the circle that circumscribes any given triangle. And because a triangle is determined by three non-collinear points, Euclid's proof essentially says that three non-collinear points in the plane determine a unique circle. And I like this because therefore it is convenient to think that these curves are actually arcs, because an arc is very easy to be calculated. It is the portion of the circle that passes by 3 points. Thanks to Euclid for suggesting, okay? And two of these points are fixed and known. It is x0, y0 and x100, y0. So I just need to determine the position of the third point to calculate the complete circle. And any point in the curve could be calculated with a formula. So basically, I only need one information to calculate the complete curve, and that is the compensation value for x50. That could be something like -5, -10, or similar. Therefore, the only point that is really necessary to describe the complete curve is just the compensation value for 50%. Only one number to calculate all the others. Isn't that easy? So this is it. This is what I call NPC curve, natural plate compensation curve, a perfectly smooth arc of circumference that passes by 3 points, and it is described only by the compensation value of 50%. Let me just remind you that this compensation is calculated from SCTV measurements, not Murray-Davis. The compensation curve built in this way has several great advantages. First of all, it describes uniform and proportional visual spacing of the tones between the 0% and 100% area coverage. And then it is perfectly, numerically, geometrically, Euclideanly smooth, okay? And what does it mean to have proportional and equidistant visual spacing of the tones? It means that all the segments that are describing the compensation curve have the same length. This is quite obvious when we think of a linear plate condition like 10, 20, 30, 40, and so on, right? When we move to a compensated condition, all the segments will be slightly longer, but they will maintain the same length between them, resulting in an arc of circumference. And what could be smoother than an arc of circumference? Why do I insist on the importance of smoothness? We know very well that smoothing the values of the curves is an activity that could be very time consuming and often brings uncertainties related to the possible momentaneous behavior of the printing condition. Do I really need to compensate for those bulges in the curve? Shall I expect those humps every time in the future prints? Of course, we might not know if such hysteric values are related to momentary circumstances. Will they happen again the next time I print exactly in the same way? The result of one unsmooth or irregular compensation is a plate that will definitely print unsmooth and irregular tone transitions, especially when we have vignettes fading to zero. And you can see it already on the plate. Try to take a backlit look at the surface of your compensated plate and you can judge yourself. Just take a look at the vignette fading to zero. If you see a movement in those tones, there might be something that could affect printing in a negative way. That's why it is so important to maintain the same aspects of equidistance and proportionality of the tones when we move from a linear to a compensated condition. This is the scope of NPC curves. As you might have noticed, the NPC curve does not really compensate for a specific print result. It actually sets a different starting point or a starting baseline, a sort of linear curve, okay? A different basement for plate values, described by a perfectly smooth sequence of values that preserve uniform visual spacing of the tones between the non-printing area and the 100% coverage on the plate. With this method, it is very easy to define preset compensation curves, like a linear condition for absorbent substrate with a moderate ink volume, or maybe a -5 that gives a light compensation for absorbent substrate and a higher ink volume, or a -10, a moderate compensation for non-absorbent substrate and low ink volume. Or we go to -15 with a kind of a harder compensation for non-absorbent substrate and moderate to high ink volume. Going to -20, this is a very strong compensation for non-absorbent substrate like plastic with a very, very high ink volume. Maybe in this case it's really better to use a lower screen count. Do you remember the early days of digital ablative plates? We were so happy because thanks to digital plate making, the dots were smaller and plates had a sort of built-in dot gain compensation. So 50% nominal was kind of 35% on plate, kind of minus 15, right? Well, then we grew wiser and we discovered the meaning of oxygen inhibition and how to control it. But this pre-compensation was really very helpful, and many users were not applying any further print curves to their plates, just the bump. Joe, can you please launch the second poll so I can ask
I will.
a question? Thank you.
While that's open right now, can I throw a question out there for you that came from the last poll?
Okay.
And Steve would like to know, is there a Flexo ISO target reference?
Is there a Flexo target reference for what? For
curves. I think it came in right after the last poll.
Okay, Flexo target reference could be, many people are using the curve that is published in the 126476. In the last edition, this curve was no longer included in the document, and many people are using the target curves from the CRPCs, or using their custom curves, or using the curves that the vendors of the workflow and imaging rips have included in their system. Okay, so there could be several, but there is no one specific for Flexo. That's why when we discussed about SCTV, we were promoting the use of SCTV because actually it is system independent. Okay, so SCTV allows to build a curve, a linear curve, with the purpose of having let's say a color linearized on itself, regardless from the printing system. That's why I love SCTV.
Yep. And I'm going to just go ahead and end this and share the results. And I'm going to answer this question. Somebody just asked, what is CRPC? And the answer there is
CRPC is
reference printing condition.
Yes, printing conditions from the ISO 15339, and these are the new target references that we use in the industry. Do you know the compensated value for your 50? Yes, of course. That's great. That's great. Yeah. Yes, of course. And funny, it's 50 and 50% results, and in 68, which is actually the value. You see the percentage of the answer.
That is really funny.
68.7. Okay. So you have good knowledge on how your system is running. So let me show you something. How do we implement and how do the NPC curves fit within our flexographic workflow? So with using NPC curves, we can start as we do now with our typical linear plate, and we do our optimization run or runs because we have learned also from, I remember when there was the fall forum in 2019 when I was in Charlotte, that you were showing the complete process that you did with the university, several steps to define surface screening, to define the minimum dot. So the optimization runs could be several runs, not just one. Okay, so we define the appropriate NPC curve with the, and then I will show you also some screenshots on how we do that. And we output a compensated fingerprint. Remember, always print compensated fingerprint test forms. Don't print linear fingerprints, please. That could also include a color target for characterization or elements to calibrate in gray balance. If necessary, we produce the ICC profiles and device link profiles for color management and conversion, and we go on with production. I said if necessary because if you're calibrated to G7, you normally you don't need any ICC profile. You could do without ICC profiles. So here is an example of how to use the NPC curves. First, we start by measuring this in CTV, the tone values of the patches from a linear plate. and we calculate the compensation aiming to a linear target. We view the compensation in TVI, okay, and we select the NPC curve that best matches the compensation. We would then use the values of that NPC curve in the RIP. Of course, the NPC can be also automatically calculated out of the calculated compensation values. Any RIP normally allows at least two curves, one plate curve for plate calibration or linearization, and one print curve for dot gain compensation. And the best use for the NPC curve would be to input values in the plate calibration curve. Okay, this leaves the possibility, if necessary, to add one or more for further print curves for eventual dot gain, refinement, or gray balance. If the plate system requires any bump, okay, no problem. What happens if we require a bump value on the highlights? We just need to rotate the first point, x0, y0, to a different position, okay? So we know the bump value, it's 1 to 5, 1 to 4, whatever it is, and we can move the circle. The arc of circumference is now still made with the 3 points, but the first point is not at x0, y0. So when using lamps plates that require a further adjustment on the plate values with a bump on highlights, the bump value can be easily incorporated in the NPC curve. It is just a simple rotation of the arc of circumference. The values described in the NPC curve can have any sequence, every 1%, every 256 steps, or whatever structure. It's text, so it can be exported in any and used in any RIP. Okay. But there is something here that is more and very, very interesting, okay? Compensating with NPC curves brings the individual colors closer to their colorimetric linearity. What does it mean? This means that we can get closer to gray balance just by adjusting single color with NPC curves, okay? So when I do my optimization run with one single plate, I calibrate with the NPC, and my colors will be much closer to colorimetric linearity. Of course, you can see here the image on the right shows a typical split image, only black and colors from a fingerprint that was only compensated with NPC curves. Of course, NPC curves are not meant as a replacement of gray balance calibration, absolutely, but they will be a fantastic help to get closer to the target. Just think of, you have to jump from here to a distance of 3 feet, okay? And you have to do it every time. Okay, can you do it with one single jump every time? And what is your accuracy and what is your consistency in doing such a jump? And if you had a system that takes you every time mechanically, takes you 10 inches far from the target, and then you have your jump only has to cover these 10 inches, would your accuracy and your consistency be better or what? So I consider the use of NPC a great help also for the process that comes after. So for whatever is connected to fingerprint and characterization. But the advantages don't stop here, because all the players within the production workflow can benefit from the adoption of NPC curves. And the first benefit, for sure, from adopting NPC curves is a much better communication, much clearer and better communication. A typical example is in naming of the curves. A C31 curve, according to different workflow systems, could be a 50% nominal that prints 81, so it takes plus 31 and it gets compensated to 36.4. For another workflow, a C31 could be a 50% nominal that goes 31 compensated and has a certain shape that in that case it's named C with the letter C. With NPC minus 15, a 50% nominal is 50% minus 15, 35. Okay, so NPC gives a clear information on what is the value on the compensated plate and also the nominal value, of course. Final customers can easily understand the expected characteristics of the selected print providers and rely on a production team that is aligned on common interpretation of tone values and compensation curves based on CTV measurements. By the way, have you ever tried, if you are a professional in pre-press or printing, have you ever tried to explain to a brand owner or a graphic designer why that 30% that they entered in Illustrator on their artwork, you know, it's correct, it prints 45, it's not a defect in printing, it's not a defect in plate making. Sometimes they, you know, 30% enter in your artwork and then 45% printed and measured. You know, it might create some confusion. Pre-press providers can use NPC curves to calibrate proofing systems as well and easily match tone values on special colors and also CMYK. Because NPC is based actually on SCTV. Many pre-press systems are already calibrated in SCTV for proofing, just without even the NPC with the straight compensation. Different curves needed for different volumes of analog scrolls will be very easy to target, and color profiles will rely on a closer colorimetric linearity of CMYK channels. And if you spend a lot of time in pre-press for retouching those images, you really will enjoy the extended tonal range allowed by SCTV calibration. In plate making, compensated plates will be very smooth. No more wavy vignettes due to compressions in compensation values. And it is so easy to define pre-compensation values. You know, if you know that if you're a pre-press provider, a repro house, you're starting with a new printer, and you know that printer has two high analog volumes, and he wants to print with a too high screen count, why would you print a linear plate showing a 30% dot gain to be further compensated? Okay, so it's a help also to get closer to results. Process control is easier because when we know and when we can exactly calculate the compensated values on the plate for any value. Finally, printers can easily control plate values before production and confirm that the correct compensation was used during plate making. Grays are more likely to be in good balance and even without any specific calibration. Again, NPC is not meant as a replacement or substitution of G7 calibration. And it is just so easy. 50% reads 50. Okay, for printers, it's really very easy to work with this system. And here you can see some typical values for compensation curves. But of course, the values of NPC curves can be calculated for any input values measured in SCTV or CTV, as we want to call it. Let me show you something also about the use of bump values within these curves. So here I have some measurements that I took from a step wedge during one optimization run. And from these values, I can calculate the standard compensation aiming to a flat target. So here is the print TVI in red, and the gray it is the calculation of the compensation straight from the print CTV. And you see they are quite irregular and wavy, as it normally happens with these print curves and compensation curves. So instead of wasting time in smoothing all these values, I will find one NPC curve that best fits this compensation. Here there is already a suggestion. It says NPC minus 17. Okay, so let's select the NPC minus 17 and see how it looks like. So it's a blue line. Okay. Of course, it won't perfectly match the gray line, as well as any smoothing won't match the compensation from any calculation, okay? Be it in SCTV or Murray Davis or whatever, okay? But now, at least I have a perfectly numerical, natural, smooth curve for my plate.
Stefano?
Yep.
This is Mark. I have a question for you.
Yeah.
ESCO Press Sync uses predefined smooth curves. Wouldn't these be considered NPC?
I have users with NPC running these numbers on ESCO systems as well. So yeah, ESCO system is, it is, it's really working very nicely, and you can use this the NPC values on the ESCO system as well.
Great, thanks.
So when I get my values, I can export the values for my imaging RIP, and I can load them into my curves. So how about using a plate system, like a lamp system that requires a bump? Okay, of course the bump was applied when producing the plate that we use to print our optimization test. So first we define the necessary NPC curve, okay, and then we say, yeah, there is a bump, and we enter the bump value. Here it is 1 to 5, and the complete NPC will rotate to incorporate the bump value, and I will obtain the values I need for compensation. And then I can export the compensated values, including the bump. In this case, I entered a minimum dot of 1.5 here. And this operation is of course required only when the workflow or imaging RIP does not allow more curves. Otherwise, ideally, I would have separate curves for bump, calibration with NPC, and maybe further print curves for gray balance. Okay, so if there is any question, I hope that at least I could make you curious about this new method, and I hope you appreciated how simple it is, and really you would be amazed to see how easy and fast its implementation is. With this, I say really thank you very much to FTA and the FQC First Committee for this opportunity. Grazie, really I enjoyed very much this session. So if there is any question, I'm ready to discuss.
Stefano. I got one here for you, and I apologize for the noise. As quickly as we started, I had a service call here. So this one goes back to the question Mark hit you with, and that is press sync curves also express different shapes versus symmetrical. So some press sync curves would appear to fit the suggested profile of NPC curves. I guess it's more of a comment.
Yeah, probably yes. Again, when I started this work on the NPC curves, I was thinking like, if I consider a linear plate, a flat linear plate where I start from, when it is compensated, yeah, it could be like a wavy, very smooth and wavy. You can also have smooth and equidistant, but still having slight compressions in the compensations. With this method does not have any sort of compression at all. Okay, it's numerically perfectly smooth and without any compression, without any wave. Of course, if you need to, especially if you work with gray balance, your inks, when in the transition between 0 and 100, they will not be flat or steady on the same curve. They would probably cross each other with the curves. And these refinement curves can be entered as a print curve, because those extra curves are referring to printing. I see the NPC curves more on the plate size, on the plate preparation, to be ready for printing in that condition. Okay, so I like to see the NPC like a new basement. Instead of linear, take it to another, let's say a curved linear condition, if we can say that.
All right, Stefano, there are no other questions. Once again, I want to thank you for doing this for us. We really appreciate it. And folks, if you have any questions for Stefano, please feel free to reach out to him. And also, I want to just point out, over the next few months, we're going to be presenting this year's Technical Innovation Award winners. They'll be making presentations at our Membernars. So keep your eyes on our website for that. And we look forward to seeing all of you next month. And Stefano, thank you again.
Thank you very much. Really, I appreciate this and enjoyed the session. Thank you very much.
Thank you. Bye-bye, all.
Bye.